This is Sean Zernick with Internet Work Consulting. I'm doing a series on programming practices. This episode is Nesting like a Chicken Farm. When referring to nesting, I'm talking about a block of code and the unnecessary nesting of code blocks. What is a code block? Please refer to the code to the right. A code block is typically indented. On the right, we have three code blocks. One block, the function, containing the try block followed by a catch block. Blocks usually have their own scope. That means items declared inside that block cannot be seen from outside that block. There are exceptions to all rules. JavaScript and modifiers like public and protected are examples. In Visual Basic, common blocks are if statements, loops, case statements, and try-catch error handling. In C#, blocks begin with an opening squirrely bracket and end with a closing squirrely bracket. A block that is usually problematic and can be avoided is checking for errors before completing a task. Let's use a common logical process, baking a cake. The directions state that when the oven is over 350 degrees, insert the cake and bake for 30 minutes. I've written that as code. If the oven temperature is greater than or equal to 350 degrees, add the cake to rack 0, which is the first rack in the oven, and wait 30 minutes before returning the baked cake. Now let's consider the stupido that puts the cake in the oven when it's 450 degrees. Because our loved stupido burnt the cake, we must modify the logic to prevent this from ever happening again. The following is a code that only allows the cake to be inserted if the oven is within plus or minus 10% the target temperature. Notice the nested if blocks. If we continue to prevent every possible problem, which is what your code will need to do for it to be bug-free, you could be nesting ifs 2, 4, 8, 16 times. Imagine you fat-fingered the code and you opened more blocks than you closed, with 16 different ifs. Have fun cleaning that one up. Secondly, when you have that many error conditions to handle, the handling is done with the check out of sight. This makes it hard to determine which error you're working on. The solution is to handle your error checking in a way that does not require nesting the logic within the check. For example, if the oven is less than 90% of 350 degrees, throw error oven over temperature. If the oven is over 110% of 350 degrees, throw error oven over temperature. Now the errors have been checked and confirmed non-existent. We insert the cake onto rack 0, wait 30 minutes, and then return the baked cake. Your error checking will be of if error, throw exception until all errors have been checked, followed by executing step 1, step 2, and so on until you return. Following this form eliminates nested code, makes adding additional error checks simple, and increases the overall readability of the code. Limiting block nesting can be accomplished by encapsulating the block within a function. In an if statement, it would look like the code shown. If condition is true, do something, else do something else. This is more so necessary in case statements because the number of cases. Try to avoid more than a line or two of code inside each case. Do not forget the break. Finally, another block nesting scenario that occurs commonly is the switchboard. Switchboards can be accomplished with ifs, but that's why we invented select case statements. This is the equivalent case statement. Notice on both, we encapsulated the logic in a function named handleQuarter. Finally, we get into much more complicated nestings. Let's consider a database and a row from the table. Our row object must know its state to determine the SQL update, insert, and delete actions to take. For this to work, we must have the original values and the changed values. These will be stored in a dictionary of string keys representing the columns mapped to the object so we can hold any data type in the object. We also need a boolean is deleted to determine if the row was flagged for deletion. From this, we know that if the original's dictionary is empty, the row must be a new row. We also know that if the changes dictionary has any values, the row has been updated. When dealing with this complexity, 2 possible values over 3 variables yielding 8 possibilities, I use a truth table to ensure all conditions have been accounted for. Notice the do nothings. If it's a new row and deleted, do nothing. If it's a new row and no changes, do nothing. If it's not new and there's no changes, do nothing. Also notice the 2 conditions where we'll delete. If it's not a new row and it's flagged for deletion, then delete it. These truth tables are great for comments before hitting the switchboard. Notice that the switchboard uses functions rather than code blocks. Also note that the reader can comprehend exactly what is going on without diving into the details of the function. And finally, back to our cookie cutter answer for not nesting code. Encapsulate the logic in a function. It's finger licking good. And the final rule of thumb, if you're nesting more than 2 blocks deep once inside a function, you must restructure your code to limit the nesting to no more than 2 deep. Again, this is nesting like a chicken farm, one in a series of programming practices. If you enjoyed this video, please feel free to share it and make sure to subscribe to our channel. We look forward to seeing you in the next episode.